Thank you very much, Dean Taylor. I've been with Dejero for about 3 years now. I was in public safety. I'm a retired sergeant, honorably retired from San Diego County Sheriff's Department. Worked there for 30 plus years. The last 5 years I was in major crimes, doing mostly UAS work. So we were doing a lot of stuff related to video and transmitting video back to different locations, warrant services for command and control, actual missions throughout the county of San Diego, which is as big as the state of Connecticut, and so forth. So, Jehan, I know you're doing some funny thing with the microphone. Am I loud enough? Can everybody hear me okay? I'm sitting at the world's...
Or is it? Yeah. Okay. Yeah, we've got the mic on.
Okay. Okay, great. I'm at the world's longest traffic signal. I've been sitting here waiting to make a left turn for about an hour. Eventually, I think I'm just going to run the red light and risk it. One thing that I do want to talk about a lot, and Kevin was very clear on his description, but when I was a deputy, I was very visual. So when I first came to Dejero, I made the famous straws, right? And so these are my straws. I'm going. Gonna go through this light. Never changed. Anyway, the straws are my way of representing what happens in Dejero technology, and I look upon each one of those very small straws as a SIM in your cradle point or a Starlink Mini, which the best days I've been able to do is about 10 to 15 up, and seamlessly putting that in a big pipe that you can utilize for all sorts of things. And I think that's the best part of what I've noticed about our technology is it's not so much as you've got all this great amount of data, which you do. It's the fact that, when you bring on like a ad hoc command post, when you're the first unit on the scene and you show up there, you need more connectivity because you're bringing in more communications, more partners. You want to check all sorts of applications on your phone, not just get into CAD. You can do that, and your bandwidth is increasing without you even having to think about it. So that's the big strength that I've seen. And there's two parts from a law enforcement standpoint that I wanted to talk about that I want to expand on, Kevin's presentation. The first is the incident command system that we're all in the United States and, other versions in Canada. ICS is a way of standardizing a mass event, large event, whatever it is, and creating a common operating procedure so that your teams and other groups inside of your county or your state can operate with you simultaneously and understand what's going on. And in ICS, from the comm side, you have PACE, your primary, your alternate, your contingency, and your emergency. And what I struggled with over the years is, how do I set those systems up, right? Like, is my primary my radio? And if that's the case, what's my alternate? Another channel on the same radio? What's my contingency? Starlink, is that deployed? Do we have to switch all of our equipment over to it? Do I have to unplug the router or the switch and plug it into a totally different system? That's a lot of extra work for you in a very busy and dynamic environment. And when that happens, you have to know where you are. You have to know what the coverage is. I got a kick out of, I saw somebody on LinkedIn a couple of weeks ago where they said, the Leo in the field is the one who knows best about comms. And you know what? That's true. I used to work in an area where there was a dead spot. We had a drug 7-Eleven, whatever you want to call it, whatever nicknames you have for that, 7-Eleven. We had one, and I would never contact anybody in front of that store. I'd wait till they were on foot or jumped in their car so that I knew my partners could hear me on them, right? So primary, alternate, contingency, and emergency. How are you dealing with that? With the Dejero system, we deal with that seamlessly, and we're integrating it. You don't have to think about it.
Sorry,
Yep.
can I interrupt you for a second? As you're
Sure.
driving, right? And I think some folks notice, you can see the cell connection quality changing up top. And as you drove on the freeway, some of those connections actually completely dropped out. So yellow's marginal, green's good, red's like, hey, I don't have any connectivity on this modem. And in your standard environment, if you had a single fiber line or a single cell connection or a single Starlink, that's it. It's called over, right? Dean's trying to like figure out how he can redial in and connect his VPN and re-authenticate, and now it's like 2 minutes, 3 minutes, whatever. If it's an emergency, you don't have that type of time to deal with that, right? You're dealing with everything real time. And as you saw, the connections went in and out. And yes, Dean's video got choppy, but we had the audio, it pixelated a little bit. But the system is in real time trying to move the traffic to the most appropriate network, right? And we actually show that in much more granular view. So this view that we have here, this is like our high level fleet management, network management system. This is very similar to like your NetCloud or your FortiGate system. But if you go another layer deeper and you look at this view, this is what we call our web UI. And this shows you, as Dean's still driving, right? This will show you in real time the view of which network is picking up your traffic and why. So it shows you it shows you your endpoints connected, it shows you your backends connected, and it's going to populate a few graphs. It takes some time because it's getting this direct information from the device right now. And if you notice here, it's telling you, hey, this is your aggregate upload capacity, this is your aggregate download capacity. You see the colors on the graphs are different, a little bit yellow, a little bit green, a little bit blue. Those are your different cellular networks. So cell 0 is T-Mobile, cell 1 is Verizon, cell 2 is FirstNet, and as he's driving, the connection quality is changing. We are measuring connection quality for every packet. So we're looking at the RSSI, RSRP, packet loss, jitter, latency. The system's looking at all of that, and it's telling you which tower you're connected to, which band you're connected on. Are you really on FirstNet? Are you not on FirstNet? And in real time, you can see it's telling you, hey, your latency is spiking on one of your networks. Your latency is stable on one of those networks. And using all of these parameters is what the system's kind of deciding based on, right? So it's saying, hey, this is a latency sensitive application. It's voice. I need to make sure that these packets stick to a low latency type of transport. This is a file transfer application. It can handle latency, but it needs bandwidth. So I need to make sure that I route those packets appropriately, right? From a first responder operator perspective, is you see much better coverage, much more reliability for your applications, and very little operational impact. So if the system works, you don't have to worry about any of this. You just pop it in and the system does the magic of, hey, I'm talking over all the networks or whatever. But it's when there is an outage and your chief or your boss or whoever comes to you and says, hey, why did it do that? Right? Or you want to go talk to AT&T and say, well, we're paying for coverage AT&T FirstNet. Why is there no coverage out there? Well, this system will tell you at intersection A and B at 6 p.m. on a Sunday why they couldn't get to dispatch, because the system will show you the real-time performance of that network at that particular location. And you have the ability to save that data for weeks, for months, for days. That's up to the end customer. But that's kind of what the system's doing. So as Dean's driving and he's talking to us and he's doing this live demo, what's happening on the back end is you're seeing the system just work flawlessly, moving traffic across all those networks. And I just wanted to kind of highlight that before we continue. And if there's any questions, please ask and interrupt us. But back to you, Dean.
Yeah, no problem. So I think I covered pace pretty well on that. The other thing from a public safety standpoint that I think about is your quality of service ladder. What we're hearing from in the field and what I was experiencing with my employment with the sheriff's department was a continued and often request for more and more data in the field. And obviously with AI platforms, that's driving this need even more. It's kind of, I read recently that they're spinning up unused nuclear power plants to power these AI server facilities. They're big, and guess what? They need a connection, and all of that intuitive thinking that's going on from those brains is done in the cloud, right? Which is really a server farm somewhere. And so consequently, if you're using those kinds of technologies, or what I see on this quality of service ladder is this climb higher. So let's see, at the bottom for life safety, you've got voice comms, right? Typically that's handled by your radio. Some people are going to voice over IP radios. Central Pierce is experimenting with that, as a matter of fact. Then I look upon life safety as a very basic CAD system, right? Where am I? Where am I going? Am I in service? Do I need help? Those kinds of things. That's at the bottom. That's been around for 20 plus years, and it's been utilized for, via the radios, or in some cases via Wi-Fi, when your vehicle is parked in the side of your facility through access points to upload ALPR information or whatnot. But now all of those systems are getting more real-time, more integrated, and require more bandwidth. And because of that, you're starting to climb the ladder. So you've got life safety. Then maybe the next step is, continuity. How do you operate? Do your fire trucks need to know how much water is on board? If you're running an ambulance, what other information other than basic patient parameters do you want to send to the hospital? Do you want to send a real-time video so that they can see what the patient is like? In a patrol car, we've got onboard cameras now, because instead of having the deputy or the Leo voice your pursuits, you can watch the camera and you can see the weather conditions, you can see the speeds, you can see what part of town you're going through, so you can be making realistic and accurate assessments of whether that pursuit should continue or whether it should be terminated. As you climb that ladder higher, think about situations you've been in where you've needed to roll out the command vehicle, the mobile command vehicle, or whatever you call it in your department. Well, all the time you're working out of the back of a patrol car with what you got in the car, right? So your needs for having connectivity increase, and waiting for that mobile command vehicle, or waiting, in our case, we finally got rid of the vehicles that needed a commercial license, but there's agencies that you need a commercial operator to drive your command vehicle. That could be hours of response before you get that vehicle. So in our environment, climbing that ladder is simple, it's built in, and it's almost automatic. And I think that's what I'm seeing in the industry today. Public safety and many other private needs is the need for that amount of connectivity in the field is increasing. Instead of having one camera, now you want 3 cameras. Jehan, I know for the G5 Summit, they're putting in 4 cameras in each vehicle. Do you want to take your body-worn camera video and get it into your platform so that the supervisors can review all of the video, or that if other individuals need access to that, your department policy allows it, can they look at that video before that Leo is out of the field, so they can continue writing their reports, reducing your overtime? There's definitely a demand for that. So at this point, I've been on the road for 20 some odd minutes. Are there any questions? I want to make sure I'm stopping to answer questions at this point.
I just wanted to also point out that our local internet connection here is my cell phone, right? So that there's that little caveat there as well, right? Because you saw Dean's video go in and out. There's a little pop-up saying, hey, your internet connection is not stable. And that's basically the example we're trying to show you, right? Like Dean's driving around in the vehicle with a gateway. He's got good comms, but wherever you're receiving this information, it could be your EOC, your PSAP, your dispatch center. If they're relying on Comcast, Frontier, AT&T, whatever single network, if that degrades, if this right now runs out of battery or just doesn't have a good network connection, like we can't collaborate, right? We don't get this real-time situational awareness. So I just wanted to highlight that on this end, we don't have our system. It's just running off of a single LTE hotspot. The other thing I wanted to show you is, this is when, you hope Murphy doesn't show up. But as you can see, right now it's mostly green, which says, hey, cell 2 is carrying all your traffic. Dean's coming in live, whatever. Cell 2 hasn't filled. But hypothetically, let's say AT&T has an outage. So I'm telling the device right now, hey, don't use AT&T. So I just turned it off. Right now, if I can still see Dean, that means the system is seamlessly starting to push traffic over Verizon and T-Mobile. The green's gone. He didn't disconnect. He's still there. He's still driving. And that's kind of simulating an outage or simulating an environment where you're on a highway, you're driving, you just lost connectivity to a tower. Right now, if that connection was truly the best connection, and if I just said, hey, you know, AT&T recovered from their outage, let's say it's been 4 hours, right? And now we're back. If AT&T's network is truly back, the system's going to quickly test it. And see, right there, it tested the AT&T network because AT&T's back. And it said, hey, I can get bundles of bandwidth on AT&T. It's going to seamlessly move the traffic back to AT&T, right? And while we did that simulated outage, simulated failure, we still have live video, right? You still have that 911 call. You still have your evidence going wherever it needs to go. So on the front end, the system's really simple, but on the back end is doing a lot of real-time handling of the network and the packets to make sure that you get consistent, reliable connectivity. Especially as Kevin said, if you're moving to the cloud, you want to make sure that your network connection is as stable and consistent and available as possible. So as Dean said, if there's any questions, we're happy to answer that, but that was kind of the demo that we wanted to show you. We just didn't want to do like a presentation. We wanted to show you guys a real-time experiment. So thank you, Dean, for doing the drive and not crashing the car, because we were worried about that too. But yeah, I think it's all gone well. So we can conclude and we'll open up for questions if you guys have any questions or comments or.
What's the price structure